All right, one final, I would say, pretty advanced example of an optimization problem. So a billboard of height B is mounted at a height H on the side of a building. Excuse me. So here's a billboard. We're looking at it from the side view, right? So it's of height B, and it's mounted at a height H on the side of this building here. And we want to know how far away should the observer, so here's the observer. How far away should the observer stand from the building in order to maximize the viewing angle theta, right? So we're trying to find x in such a way that will maximize the angle theta. Okay, so we've seen this system before in a related rates problem, and I think I mentioned that we would see that same system again in one of these optimization problems, so here it is. So we need to find x that will maximize theta. And also, we'll need to introduce this other angle alpha in here that will also play a part. So we'll need to figure out how to write this thing down in terms of x as well. Okay. Okay, so in this situation, our goal is to find x that will maximize theta, given that this height and this height, those things are both fixed. Okay. So how do we relate all these quantities? Well, we've seen this exercise before. I know that tangent of this total angle theta plus h is equal to the opposite over the adjacent. So tangent of theta plus alpha, sorry, not theta plus h, theta plus alpha. Tangent of theta plus alpha is b plus h over x, right? B plus h over x. And so I'm trying to maximize theta, so my goal should be to write theta as a function of x, right? Trying to find an x that will maximize theta, so let me write theta as a function of x. So I can take the tangent inverse of both sides, and that says that theta plus alpha is equal to tangent inverse b plus h over x. So now I've got this other issue with the angle alpha, right? And it too depends on what x is. So this thing is not fixed. So I need to try to write this thing down as a function of x. Well, how do I relate alpha to x? Well, I know the tangent of alpha is equal to h over x. So tangent of alpha is equal to h over x. And now I can again take the tangent inverse of both sides. That tells me that alpha now is equal to the tangent inverse of h over x. So now I can take this alpha and move it to the other side. And so now that tells me that theta, written as a function of x only, it's the tangent inverse of b plus h over x minus alpha, which is the tangent inverse of h over x, right? So remember, this thing is alpha. So now our goal is to maximize this function, right? Find the x that will maximize this function. So I just call it theta of x to indicate that I've written the angle theta now as a function of x. Okay. How do we do that? Same way as always. Take a derivative, set it equal to 0. So the derivative of tangent inverse, right? It's 1 over 1 plus the thing in the parentheses squared, and then tack on the thing in the parentheses, the derivative of the thing in the parentheses. So remember, the derivative of 1 over x is negative 1 over x squared, and this is a constant, so just multiply by the constant. So here's the derivative of the first piece, right? And then minus the derivative of tangent inverse of h over x. So that's minus 1 over 1 plus h over x squared, and then tack on the derivative of h over x. Well, that's negative h over x squared. So the derivative of this thing is negative, and that will cancel with this negative, and that's what gives me the positive. So I take my derivative here, set it equal to 0, and now I just need to solve for x. So now the rest is algebra. The calculus is done, the rest is algebra. Okay. All right, so the last thing we need to do is some algebra in order to solve this equation for x. So remember, this was the derivative of theta of x, right? So an expression for the angle theta as a function of x. So that's the derivative, set it equal to 0. And so now we just need to solve this thing for x, and we will do that in terms of the constants b and h. Okay. So I've got negative a fraction, positive a fraction. I'll take the negative one and just add it over to the other side. That's how I got from here to here, right? Just add this chunk over to the other side. And then to get from here to here, well, for fractions to be equal, their cross products have to be equal. So h over x squared times this thing is equal to b plus h over x squared times this thing, right? So that's how I got from here to here. Just for fractions to be equal, their cross products have to be equal. To get from here to here now, I'm just dividing, well, I've got an x squared in the denominator, so I can multiply through by x squared. That will cancel both of these x squareds in the denominator. And now I can distribute the h. So h times 1 is h. And then h times this fraction b plus h over x squared is just h times b plus h squared over x squared. And then do the same thing over here. B plus h times 1 is b plus h, and then b plus h times h squared over x squared. And so now, if you like, you can cancel off the h's. And so now we are just left to solve this equation for the variable x. All right, continuing on from the last slide, we canceled off some h's from both sides and we wound up here. Again, remember the goal is to solve for x. So let me take this fraction and subtract it from both sides. So I will take this fraction, right, whose denominator is x squared, and subtract over to the other side. And so now these denominators are the same, so I can write it as a single fraction and just subtract the numerators. So I get h times b plus h squared minus b plus h times h squared, all over x squared is equal to b. Again, trying to solve for x squared. So here I can factor out a b plus h, and I can also factor out an h and then combine like terms. So when I simplify this thing, it just becomes b plus h times b over x squared is equal to b. So now, if you like, you can cancel the b's and you're left with a 1. Multiply both sides by x squared and then take the square root and you get x is equal to the square root of b plus h times h. Really plus or minus, but we don't want the negative one, right? We know that b and h are both positive terms. Well, that doesn't matter. Anyway, we know we want the positive distance for x. So this would be a good final answer for how far we should be away from the billboard in order to maximize the angle.